All right. For the recording, sorry about that. We missed the first 12 minutes, but I wrote everything on the document camera, and we'll get back to that in just a bit. Actually, the recording can see it. Let me just show uh, what I wrote on my document camera. So that's what we had so far for the class. Let's go back to Moodle. All right. Besides getting you the office hours for Jose and I have one more submission link here. It's another 5 points of extra credit. We'll come up with some problems during class today. I'll write them down so you'll have maybe a page of problems for this 5 points extra credit. Okay. Now, if you did well on the previous exam and you think you did well because you did some other extra work like making cheat sheets, making flashcards, making more roadmaps, whatever um, benefits you, whatever your learning style um, works best with, keep doing that. Okay, keep doing that in the next 3 days. Chat. Yeah. Okay, so let me go back actually to our our notes. Are there any questions about Moodle? This one's, I think, a little more organized than last week. We'll have Friday's notes and Friday's recording posted as well, obviously under Friday. Okay. Next is maybe some problems. Um, good. Actually, why don't we take care of office hours? I'll go first. For me, today. I'll go. I'll go 3 to 4:30. Uh, Friday, and then for the weekend, um, second, let me figure this out. 11 a.m. Eventually, I'll get this onto the announcements as well later today. 11 a.m. till 2 Saturday, and this will be by appointment. So you just have to email me. Hmm. And again, maybe let me figure this out. I should have done this before. Um, how about this? Let's expand this a little bit. Let's go to 3 by appointment. But here's the kicker. But you have to come with another person. Most of you are on GroupMe. I think that might be the best thing to do is go on a GroupMe and say, is anyone available on Saturday at 2 p.m.? I have some questions about synthesis. Can you come with me and meet with Dr. Gabriel? Okay, so instead of having individual appointments, I'm kind of curious to see if we come in pairs or in small groups, whether that will encourage more people to come and maybe I think it'll be less intimidating and less boring if you come with a friend. So, but you have to come a at least one classmate. And maybe that will also encourage you to use each other, right, to help study. Next Sunday, I don't know. We do something. I can't. Oh, I can't do it. I can't do Sunday evening actually. Um, so let me do again. Maybe if I'm an early riser, 9 a.m. Yeah, sorry about that. I can't do Sunday late afternoon. So let's go to 2 o'clock. Same deal. You all are gonna have to learn to come to me because very exciting. Jose is starting medical school um, on Monday, and he's abandoning us. He could be around maybe in the evenings, but uh, for some reason his priority is medical school and not class. So that is my office hours, Friday, Saturday, Sunday. How about Jose? Can you speak up? Okay. Can 1 p.m. to when? Or can we just make it forever? Really? What about Sunday? Yeah. By appointment, by appointment, by appointment. All right. Mm, Man, I was gonna say something. Okay. Let's talk a little bit about the material, and then we'll get you some extra credit. These notes will be posted probably half an hour after class. Um, Let me just double check if I'm still recording. Yeah, I believe I'm recording. All right, let's set Unit 4 aside. Let's take a look at Unit 5, which was the carboxylic acids, say Ca. Besides the reactions, not not everything's going to be reactions. What was unusual? Not unusual, but what were some topics that we saw in carboxylic acids that don't aren't really directly related to reactions and synthesis and mechanisms? You do have nomenclature, carboxylic acids. You do have a little bit of hydrogen bonding, and then also acidity. Anyone else have anything to add? Go ahead and speak up. Let me just look through my notes. This is what I do when I make up the exam. I have a pretty good idea what's there, um, but then I quickly scan just to make sure I'm not missing anything super big. Uh, uh, Reactions. Interesting. For the decarboxylation, I did talk a little bit about that six-member transition state. Is that going to appear on the exam? Maybe no, maybe yes, maybe 2 points, 3 points. But I did talk about transition state. It's that drawing with the dotted lines to indicate bonds being halfway made or halfway broken. It was very quick, actually. It was the end of one of the videos, and it looked like this. Because a transition state is at the top of the hill, very unstable, right? What we can draw and what we can isolate, we can isolate the starting material, the intermediates, and then the product. But those things at the top of the hill, It's literally what does the molecule look like between the two valleys, right? So the valley, we have the starting material valley, and then we have the enol valley. But what did the molecule look like beforehand, or not beforehand, but in between? Well, you're looking at the bonds that are being formed and broken. So this bond right here is breaking between the oxygen and the hydrogen. That's why it's a dotted line. What about these lines and dots at the same time, like 1.5 bonds? Well, it's 1.5 because for this bond right here, the one I'm pointing at, we have one bond and we're starting to form a second bond to make it double. So halfway between 1 and 2 is 1.5. That's the idea for transition states. Are there any questions about Unit 5 before I go on? We have 11 people in the room. Oh, I'm counted. Am I counted twice? I'm counted twice, and Jose's counted once. So we actually have 8 people in the room. For those 8 students in the room, is there anything you want to know? In my mind, there's a really important question. Is there anything you want to know about Unit 5 before we move on? And very, if you're very, not sneaky, but if you're thinking ahead, what is something that you want to know about Unit 5? Oh, no, Jose said it, but I need a student to say it. Because if I don't hear this question, everything's fair game. Everything's fair game. So what do you want me to do? Jose put up a little clue. I'm willing to answer that question if someone is brave enough to ask it. Uh, okay. Yes. So in class, on the videos, I talk about as many mechanisms as I can fit because I think knowing the mechanisms can help many people actually fill in the product. So I do go over a lot of mechanisms. But on the exam, I typically focus on a couple of them. And a very fair question is, well, I looked it over the mechanisms that you had on video, but are there any ones that you want us to focus on? What are the ones that are more likely to be on the exam than others? So why don't I give you a list? Okay. So after the nomenclature and the hydrogen bonding and all of that stuff, we have synthesis and reduction and decarboxylation. Synthesis of carboxylic acids are here. You didn't never need to know the Jones oxidation mechanism, but yeah, doing your stuff, you should know the mechanism. So here I'll put here no. Ooh, put it M in circle. That's how I would put it on the roadmap as a reminder. So these are the ones that you definitely should know. I'm not listing all the ones that you've seen. Anything with remove. Is that fair? Yes. Because whether you have a Grignard or organolithium, it's basically the same mechanism. You're attacking a carbon that is attached to oxygen. In the context of carboxylic acid, yeah, that's Grignard plus carbon dioxide. Sorry about that. Okay, what other mechanism? I'm not worried about the mechanism for the acid chloride. Okay, I gave it to you because it's an unusual mechanism to convert the OH into Cl. It's a little bit different than converting an alcohol to alkyl chloride. So I did give you the mechanism, but I'm not going to test that. But I am interested. decarboxylation. M. Good. Why don't we move on to Unit 6? Again, everyone has watched the two videos, so people should be familiar with Unit 6. Here's your ski slope / totem pole. Actually, someone told me in class that I should not use the analogy of totem pole. You know what a totem pole is? I don't even know who uses those anymore. With the heads on top of each other, carved out of wood, stone. What? Do you know why I shouldn't use totem pole? The analogy of totem pole. Those of you who are familiar with that culture, let me look it up because I don't want to sound more dumb than I usually am. Totem pole. Give me 1 second. Jose, do you remember why why someone told me I shouldn't use totem pole? Okay. I'm looking this up on Bing. Here we go. Okay. Maybe that student lied to me. I wanted to show hierarchy, and the acid chlorides are the most reactive, followed by the anhydrides, followed by the esters, followed by anides. So we're always going downhill if you think of this as a ski slope. All the arrows from one derivative to the next go downhill. Someone told me that a totem pole, the most important figure actually is at the bottom, not at the top. So the hierarchy got switched because I think of the most reactive as probably the most important because the most reactive can access the other three or the other members beneath them. So we'll go with the ski slope. How do you get to the top of the ski slope? You take the ski lift. So there's no way to go from the amide to anhydride directly. Instead, what is the strategy? Take the amide, hydrolyze to the carboxylic acid, take the ski lift to the acid chloride, and then ski down to the anhydride, or ski down to the ester. Okay? So that's how you get an amide to be one of these three on top. So let me write that down. Unit 6, Ca derivatives. This map, with all these arrows, it takes 15 seconds. Not to fill in, but to draw all the arrows. Because, again, all of these can be hydrolyzed to the carboxylic acid. You take the ski lift up to the top, and then everything beneath can be made from anything that's above them. Okay, so you have all these purple arrows. We do have one arrow off to the side, how to make it nitrile. So the mechanisms are, again, like very analogous. What you have to worry about in terms of mechanisms and in terms of reagents is that these two are most reactive and you don't need any catalysis. These two typically do need catalysis or heat. Okay, it just depends on the reaction. Let me think about the mechanisms. Okay. All right, so this is first video. Really no mechanisms there. We start off with hydrolysis. Yeah, hydrolysis is important to know the mechanisms for, except for the nitrile. So I'm not going to force you to go through the mechanism for nitrile. The thing is, again, if you know how to do the mechanism for acid chloride, you could do that for anhydride because they're both very reactive and all you need is water. For these two, you have to have acid, so you go to protonate first. and then you go ahead and attack with water. So you need to know the hydrolysis for all four. What else? Let's move on. After hydrolysis, you have alcohols, but honestly, that's the same. It's just water, but instead of a second hydrogen, you have this alkyl group. So that should be analogous as well. Hydrolysis and addition of alcohol. What do you get when you add alcohol? When you add alcohol, you replace the leaving group with an OR group, alkoxy. So acid chloride plus alcohol gives you ester. Acid anhydride plus alcohol gives you ester. Okay? Your alcohol is giving you this alkoxy group. So really, in terms of reaction with alcohols, it's acid chloride and hydride. And there's that weird one. If you react an ester with an alcohol, you could do what's called transesterification. You could replace that alkoxy group with a different alkoxy group. And that was shown there. And it still has an M. So that's transesterification. Methoxy, and we change it for ethoxy. Because amide is at the bottom, of the ski slope, we can't make an ester because that's going uphill. Is there anything else? Okay, so now we have a reaction with amines. Don't worry about the mechanism for that. But for sure, this is super important because amides are very important. Amides are all over your body because they make up your enzymes and antibodies and other proteins. The best way to do an amide bond in the lab is to react an acid chloride plus amine. And I mentioned that. You have this video? This was video number 3, so maybe some of you have not watched this yet. But let me give you a note for that. Um, for addition of amine. But you need to know how to use that to make amides. We'll go over that. I have a plan in mind in terms of how you could organize your studying. Next, you have reductions. 6D. Don't need to know the mechanisms for those, but obviously you do need to know how to reduce these functional groups. We have some review reductions, and the new ones deal with the derivatives, ester, amide, and even nitrile. These are tricky. Okay? Again, if you haven't watched the video, you'll take a look at that. I'm just trying to get a head count for what mechanisms I want to check. Okay. For the last couple of reactions, if you have not watched the video, this is not going to make much sense. But definitely a mechanism for saponification. Those of you who know French, that means soap. Savon means soap, I think. And this is how you make soap. Because the starting material, starting ingredient for soap is an ester. And you're going to saponify. Another word for saponify is hydrolyze with base. I don't know. How do you say soap in Spanish? One more time. Sorry, one more time. How do you spell it? Okay. Besides saponification, I kind of like the mechanism for Grignard plus ester. And again, if you haven't seen the video, you'll watch that. It's kind of cool because here you add, oh, it's JABON. The Grinder plus S is kind of cool because you add the Grinder twice. Okay. To tell you the truth, oh, totally forgot a mechanism that's important. Um, Fisher, Fisher. Yeah, I'm gonna add it. Okay, try your best. Um, I know time's limited, but if you've been studying along the way, you know, a lot of these are automatic. Hydrolysis should be automatic. Fisher is the tricky one. Decarboxylation may be the tricky one. Grignards are should be automatic, right? And not only Grignards in Unit 5, but we talked obviously about Grignards in Unit 4. So let me put that also. Just to remind myself. Is there going to be a lot of mechanisms? I don't know. Maybe you like mechanisms? I can make it worth maybe 2 mechanisms for a total of 16 points, 16 to 18 points. Let's go with that for now. So mechanisms, maybe 2 problems uh, equal 16 to 20 points total. Right. So that's mechanisms. Let me give you some extra credit now. The first extra credit is, let's see what I can do this. And I'll start it on a new page, and I'll keep it a running list. So this is the extra credit to hand in. Let me show you actually. Here, uh, I am making this due tomorrow, 5 p.m. But it should be pretty easy, and you could get it done, later this afternoon if you have plans tomorrow. So let me give at least one problem right now. Okay, new page. Let me go to the top. This is extra credit due Saturday. But again, if you're up to speed and you've been keeping up, this can easily be done in about an hour today. Saturday, 5 p.m. No late submission. So if you do, get something in if you can. Even if you do only half of these problems, you could still get half the credit because it's going to be a total of 5 percentage points. The first one is 4 plus, we'll go with plus 2%. What can we do to organize stuff? Okay, I'm just going to jump right in it. If you notice, and I mentioned this on the video, even in video 2, an early video, when I talked about hydrolysis, I said we're going to learn hydrolysis for the acid chloride and see what happens, and do hydrolysis for the other derivatives, even nitrile. So the way that I teach the material is I give a reaction and I say, well, how does this reaction operate with the carboxylic acid derivatives? How does addition of alcohol? And I did all the derivatives. Well, all the derivatives except amides. Um, and then I did addition of amines, and I did the derivatives. But what can you do? Instead of organizing it by reaction, okay, like for instance hydrolysis, we could organize it by starting material. And that's my challenge to you. And the first one's a doozy. Because out of those 4 derivatives, the one that has the most reactions are the esters. We'll make this worth 3 points. And this is worth your time. Give you an ester. I want you to give me a roadmap for esters and draw every single reaction that starts with an ester. Now, obviously, you have ester plus amine. I don't want you to draw an ester to a primary amine, an ester with a secondary amine, an ester with a tertiary amine. To me, that's all the same type of reaction. But you have addition to amines, addition with alcohols. Okay, you have reduction. Okay? I think I'm still recording this video. I'm not going to write it down. Your task is to go through your notes and go through the videos. So based on video, the other issue is you don't know, at least I don't know, but I'll review my notes. I don't know if all the reactions for esters are in Unit 6. There could be one in Unit hiding in Unit 5. There could be one hiding in Unit 4. Okay? It's very hard to find the one perfect categorization technique for reactions because they're all interconnected, right? So not all the ester reactions, I know for a fact actually, not all the ester reactions, oh wait, 1 second, I might take that back. But you can't assume that all the ester reactions are in Unit 6. And I want an ester as the starting material, So based on the videos, draw a map with ester as starting material. So again, the way that I taught, I categorize these derivatives by the type of reaction: hydrolysis, addition to alcohols, addition to amines. But now I want us to reorganize and show all the reactions starting with one particular carboxylic acid derivative. I got a little bit confused because I know for a fact that you can make an ester. You can make an ester with a reaction in Unit 5 and with some reactions in Unit 6. But I'm not asking for that. All these errors are going outward. Okay, so I don't want you to make an ester for this extra credit. Alright. So that's plus 3. For plus 2, and that will be it, I guess, for extra credit. I want show how to make each derivative. Because with a synthesis, if you see that your target is an ester, okay, you need to have in your mind at least one way to make that ester, obviously. And then, based on what you think will combine to make that ester, you have to then ask yourself, do I have the right starting material? Do I have the right starting material? The classic example, and I know I'm giving away an answer, is this: an amide. Let's say you want to make an amide. The classic way to make an amide is acid chloride plus amine. Okay? And hopefully you guys are piecing together, oh, the amine part is this part on the right. See, it matches. The carbonyl part is the stuff is from the acid chloride. So think about that. Your target is an amide. But what if the starting material is not an acid chloride? Okay, you have to figure out how to get to the acid chloride to make the amide. So that idea for this type of problem is, do you know what that last reaction is? Like, what do you need to have to make an ester? What do you need to have to make an amide? And I do have some synthesis practice on the last video. Let me show you that. So that video for Unit 6 will help you do these types of problems right here. Okay. So where's that amide? That's an amide right there. And I emphasize the best way to make an amide is through an acid chloride. But the problem is I don't start with an acid chloride. So do you see how that's the challenge of the synthesis? For a lot of things, you know what the last reaction should be. But the thing is, you're not given the correct starting material. You have to make that starting material into the starting material to make the final product. Okay, so keep an eye on this problem. I did this on the video, so let me show you that those notes. It was this problem right here. Okay. Down. So the problem was this, the one in black. Okay. In the video, I emphasized the best way to make an amide is acid chloride plus amine. So forget about that. Just look at your product, and the acid chloride, I think that will help make this is this acid chloride here. So I'm proposing that my last reaction will be these two mixed together to make the amide. This is a strategy. This is not the answer that I want Jose and I to look at. Okay, this is scratch paper. This is, you can even do it on the exam. Okay, because it has this little weird arrow, the arrow that's open-ended. Because this arrow means comes from. The textbook calls it a retro arrow, going backwards. So this came from these two ingredients. Now, it would be up to me to figure out whether I need catalysis or whether these are the forms of the molecules that I want to use. But again, this is a general strategy. Now look at my starting material. Okay, so I'm cursing right now because I said, man, it would be so easy if Dr. Gabriel gave me the acid chloride. Okay, but that would be just a one reaction synthesis, so obviously that's not going to happen. So now your task is, how do I go from here, not to here, but how do you go from here to the acid chloride? Okay, with you being confident that if you get to the acid chloride, you can make the amide. So now the synthesis starts in earnest. And it got kind of loopy because, well, I was literally doing this as a student. Like, I haven't seen this synthesis in many semesters. Now the thing is, there wasn't much synthesis on exam 1 because I didn't emphasize it on the videos. But for exam 2, the synthesis is not going to be as an extra credit like it was in exam 1. It will be part of the exam. Okay? Now the thing is, you have to use some game theory. You have to figure out, well, shoot, Dr. Gabriel gives partial credit. So if you know this part, okay, if you do this exercise, yeah, you'll know how to make an ester, an amide, an anhydride, an acid chloride. You could get at least partial credit by doing what? By giving me the last part. So if you give me this, I think that's pretty significant because it tells me that you know how to get to the final product. It's just that you were given the wrong starting material. All right, so this is a Unit 6 reaction, and you'll get partial credit for this. Now the thing is, how do you get more partial credit without doing the whole thing? Give me any reaction. Give me any reaction that is even partially relevant to the synthesis. So without even knowing this target, can it do anything with this alkyl halide? That gets me closer. So you're attacking from both sides. You get partial credit for the end, and you may get partial credit for the beginning. You could probably guess that, carbon-carbon bond formation is a huge deal for this exam. And the best way to make a carbon-carbon bond is through the organometallics. So take a leap of faith and make this into a Grignard reagent. Now, we have a bunch of stuff in the middle, right? But, on the exam, if I see this, the beginnings, and I see the end, that's at least half credit. At least half credit. Because it's great that you know how to start, or you have a good guess how to start, and you know the end game. You know the end game. So now the challenge is, that Grignard reagent to this. From the ski slope, and I can't find it right now. From the ski slope, you can make the acid chloride from the carboxylic acid. And then you can make the carboxylic acid from the Grignard reagent. It got kind of twisty because I tried to make the alkyl halide into the carboxylic acid, but I forgot that I should make the Grignard first. Okay. So that is synthesis. On the video, I did take care of. One second. On the video, I did take care of 3 of the 4 synthesis. So this is the last practice problems on video unit 6. I did these 3 for us. Take a look at these. So some of these are kind of challenging. Okay. This one maybe not so challenging because here I have an ester. This problem for the extra credit is going to help me with that synthesis because at least I will know how to make an ester. Okay. Whether that ester can come from these starting materials, that's another story. That's another story. Okay. So let me give you the formal extra credit for this. Show how to make each carboxylic acid derivative. Let's start with the acid chloride. So what are you doing? You are filling in this arrow. Okay. So I am drawing the reaction backwards. So you tell me how to do it. Like this is your target. The anhydride, the anhydride, I'm also going to make it asymmetrical. But you get to decide. Okay. Some of these have multiple answers. Ester definitely has multiple answers. Why do I say that? Because for an ester, again, I'm not going to write this down. You could write it down right now if you want. You could use unit 5, which is Fischer esterification. Or you could use unit 6 simply by adding the correct alcohol to the acid chloride to make the ester. You're using this purple arrow right here. 2 main ways to make an ester. Okay. Amide, you've heard me over and over again say the best way to make an amide is through the acid chloride. But let me give you this amide just to make it a little bit more challenging. This might have been a practice problem. Okay, can you figure out the amine that you're going to add to the acid chloride to get this molecule here? Okay. Let me zoom out. If you're meeting me today, did I say that I need people in groups today? No. If you're meeting me today, you can come individually. I will be in the room. Jose will be available later tonight by appointment. This extra credit is due at 5 p.m. Saturday. So you will have a chance to see me also on Saturday. But again, come with a classmate. Get that, set that up later today with a classmate. And also Jose is available before it's due as well. When I zoom out, this is your extra credit. This is a great strategy. Okay, so even if it's not worth the extra credit, could you draw me every single arrow coming from this anhydride? Can you draw me every single arrow coming from a nitrile? Like nitrile is kind of the forgotten beetle. So you don't want to lose those points if I give you a reaction using a nitrile. Right now, I can think of I'll say them out loud. With a nitrile, you could reduce it to the amine. With a nitrile, you could hydrolyze it to the carboxylic acid. And those are the only two reactions I talked about on the videos coming from a nitrile. Now, obviously, you have a way to get to the nitrile. Okay, but again, you could do this type of problem with any derivative, any of the other four derivatives. By the way, the fifth beetle, some of you saw that it was debatable. I think it's the drummer, the original drummer, but a lot of people say the fifth Beatle was the producer. I think his name was George Martin. So he was in the studio with them throughout all their, greatest albums. That's George Martin. Okay. If you don't know who the Beatles are, then I can't deal with you. All right. But I know that in the next couple of years, people are not going to know who the Beatles are. So there's your extra credit for 3 points. There's your extra credit for 2 points. All right. Is there anything else that I should talk about before we could end a little bit early if you want, and I can get started on those practice problems. Um, any questions? Do you see anything, Jose, from the group? No? Okay. Okay. Let me take one more sneak peek at some of these problems on Moodle. Okay. So guys, it is definitely worth, even though I'm only checking the first two videos for Unit 6, obviously it's worth looking at all 5 of them. Actually, let's go there. No, I don't know. Are people having trouble opening this? Um, so while this goes, let's take a look at the rest of Moodle. Um, with a lot, with a lot of synthesis, let me commit to that as well. If you guys are interested, I think you're interested. So here I committed us to mechanisms that are in worth total of 16 to 20 points. Let me commit to synthesis also. Synthesis. Man, I wish there were more points to give out. Maybe one easy and one hard. Maybe. One easy, super easy. That's going to be worth maybe 6 points. And one challenge. And all of this is approximation. One challenge which is worth maybe a little bit over 10, maybe 11 points. There's a lot of reactions, so I do have to, commit a lot of space for fill in the products. I could convert some of those fill in the products into. Are you not seeing my screen? Jose, will you see my screen or not? Can't? Okay. Sorry about that. Uh, no, don't want to do that. Give me 1 second. Okay, you see Moodle. Sorry, I'm not sure where my document camera went. Let me just try to find it. In the meantime, think of some questions to ask me. Uh, oh, gosh darn it. Okay, here it is. Okay. So I'll commit uh, maybe 17 to 19 points for the synthesis. Um, that's my train of thought. Oh, how about this? Uh, last thing. So while this is due Saturday at 5 p.m., I don't know if people like doing that forum, but I was actually very interested in the type of questions that people were coming up with. So no one has been using the forum, so either Jose's been doing a great job answering questions or not. So we'll do plus 2 percentage points. Okay, if you ask a question on the forum, uh, so 1 point for asking a question, and 1 point for answering a question, or at least giving a relevant comment. Let me show you where that is. Oh, I knew. I was good at going Moodle anyway. Um, so the forum is up here at the top. Questions, comments about exam 2. Study first, okay? Um, I will check Monday morning, who commented and who put a question on the forum. Make it a good question. Try to challenge your classmates, or challenge me and Jose. If you're totally confused about a practice problem, go ahead and put it up in the forum, and Jose and I, or maybe one of your classmates, can answer it. One more, one last thing. Let's go to the field guide or the YouTube. Again, all the videos are posted. I don't plan on posting any other video, but the very last video that I posted, again, is synthesis problems. I don't know if you can see that, if it's anything's covering it. So go ahead and watch, if you haven't yet, the last 3 videos for Unit 6 that were not due today. Um, the notes for today were for just the first 2 videos. I think that's it. I don't have anything else to say. For the lab, we're gonna have more. Well, we're gonna get caught up next week. Okay, so maybe we'll try to do at least 2, but possibly 3 labs next week. Devote your time between now and Monday to this exam. This is as good as it's gonna get, because you have nothing due in lab, and we only do have 11 videos. Okay, much not much less, but less than we did for exam 1. So this is the exam where you really want to build up your letter grade.